Hey fifth graders, yesterday we learned how to turn mixed numbers into improper fractions. We're going to do the exact opposite today, and we are going to be turning improper fractions back into mixed numbers. So let's just take a look at what are the meaning of improper fractions. They are fractions where the numerator is larger than the denominator. So for instance, 5/4, 13 halves, and 7/3. If your top number, the numerator, is greater than the denominator, we call that improper. We usually like it when the numerator is smaller than our denominator. So let's go ahead and model these. So if you have 5/4, you need to draw in 5/4. So if I have one whole unit, well, that's 1, 2, 3, that's 4/4. I need one more quarter to give me my 5th quarter. So I'm going to cut those into quarters, and I shade in one more. This is equivalent to one whole thing and a quarter of another. This is indeed equivalent to 1 1/4. Let's take a look at another example. 13 halves. I need 13 pieces of 1/2. So let's go ahead and cut this in half. If I shade in this, I have 1, 2 halves. Well, I need 13 of them. So I'm going to go ahead and cut all of these up in half and shade in 13 of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that is equivalent to 1, 2, 3, 4, 5, 6 whole things and half of another thing. That is equivalent to 6 1/2. Let's draw a diagram for 7/3. So let's go ahead and make our own diagrams. So I'm going to cut that into thirds, into 3 equal pieces. So I'm going to go ahead and shade that in. Well, that's 1, 2, that's 3/3, which is one whole thing. I need 7 of them, however, and that was 3/3. So we'll just go ahead and write that in because that might be helpful for us. Okay, I need to make sure that my next model is approximately the same size. Well, we definitely want them to be the same size. 1, 2, 3 more gives me another whole thing, and that's 3 more thirds. I need 7, so that's a total of 6 so far. I need 7/3, so I need one more diagram. So I can shade in that last third. That is my 7th third. So I have 2 whole things and 1/3. That is equivalent to 2 1/3. Okay, so let's talk about how can I go, instead of drawing pictures, how can I go straight from 5/4 to 1 1/4, from 13 halves to 6 1/2, from 7/3 to 2 1/3. Well, let's really think about the meaning of one whole thing. So remember that any number over itself is equivalent to one whole thing. So 2 halves, 3/3, 4/4, 5/5, 99 99ths, a million millionths. Any number over itself is equal to one whole thing, okay? So what we want to do if we have improper fractions is we want to know how many whole things are made up by this fraction. So essentially what I want to know is how many sets of 2 halves, which is one whole thing, how many sets of this can I fit into my 13 halves? Fitting into means division. So let's take a look at this next sentence here. When we convert improper fractions into mixed numbers, we do want to know how many whole things fit into the improper fraction, and then we want to see how much is left over. Fit into means division. Left over means subtraction. And I also want to draw a connection between mixed numbers to improper. So when we converted from mixed numbers to improper fractions, what did we do? Well, we did our times e plus e. We multiplied and then we added. Well, if I'm going in the opposite direction now, so if I'm going from improper fractions to mixed numbers, it only makes sense that I do the opposite, that I divide, because division is the opposite of multiplication, and then subtract, because subtraction is the opposite of addition. So if you're going in the reverse direction, you have to use the reverse or opposite or inverse operation. So here's our shortcut. To convert an improper fraction to a mixed number, we will divide the numerator by the denominator. That will be the whole number part of your mixed number. So however many full times that your denominator fits into your numerator, that is your whole number part of your mixed number. Then the remainder goes over the original denominator or the original divisor. That was our original divisor. So, for example, if I have 9/4, well, this is equivalent to 9 divided by 4. And we're going to talk about this on the back side, that a fraction bar is really a division symbol. So what I'm going to do is I'm going to take the numerator, I'm going to divide it by the denominator. 4 goes into 9 2 whole times. 4 times 2 is 8. So I'll kind of do scratch work over here that I have 4 times 2 is 8. And then 9 minus 8 is 1. I put that remainder over the original denominator. My denominator stays the same. That is 2 1/4. Let's take a look at another example. This is going to be 15 divided by 2. I want to know how many sets of 2 halves, fit into 15 halves. So I need to divide 15 by 2. Well, 2 goes into 15 7 whole times. 2 times 7 is 14. So how many is left over if we started with 15? Well, 15 minus 14 is 1. I'm left with 1/2, 7 1/2. 24/9. Okay, I need to figure out how many times does 9 go into 24, because this is 24 divided by 9. 9 goes into 24 2 whole times. 2 times 9 is 18. So that means that I have 6 left over. So that will be 2 6/9. And the last step is that I would love for you to simplify. Simplifying means that we are going to divide the top and the bottom, numerator and denominator, by a common factor. I can divide both of these by 3, and I get 2 2/3, and that is in simplest form. Okay, let's take a look at the back side and see another reason why we know we must divide if we are trying to turn an improper fraction into a mixed number. So here's another way we can remember it, that a fraction bar is always a division symbol. That is so critically important. So what we're going to do is we're going to take the top, or the numerator, and we will divide it by the bottom. We will divide by the bottom, or the denominator. And here we go. In general, an improper fractions means that you have a large number over a smaller number. Okay, you have a larger numerator than your denominator, and it will always be your numerator divided by your denominator, because this fraction bar is a division symbol. And remember, when dividing, we talked about this in our long division unit. When dividing, you put the remainder over divisor. And which one of these two pieces is the divisor? The denominator was your divisor. So if you always put your remainder over divisor, which we do, then that means you're always putting your remainder over the denominator. So we will put the remainder over the denominator, because that denominator is indeed the divisor. It's the divisor because it's what we're dividing by. So let's do some examples. Ooh. Sorry about that. My phone is telling me I'm on low battery mode, so I should probably speed this up a little bit. We've only got a few more examples here. So this is equivalent to 15 divided by 6. How many times does 6 fit into 15? It fits in 2 whole times. That gives me 12. 15 minus 12 is 3. So I put that remainder of 3 over my original denominator. That's 2 3/6, which is equivalent to 2 1/2. 37/8. 8 goes into 37. 4 whole times. 8 times 4 is 32. 37 minus 32 is 5. So that is equivalent to 4 5/8. Denominator stays the same. 45/4. I need to know how many times 4 goes into 45. Now, if you're having trouble doing this mentally, don't worry. You can go ahead and set this up for long division. There's no problem with that. There's no issue there. 4 goes into 4 once. 4 goes into 5 one time. Okay, I have a remainder. I'm going to put the remainder over divisor. So it goes in 11 times. So this is equivalent to 11 whole times. And there is 1/4 remaining. It goes in 11 whole times, and there's 1 additional quarter. And remember, we're doing the opposite. If I'm converting, this is just a little bit of review. If I'm converting mixed numbers into improper fractions, I'm going to use my times E plus E. So we can check our work by then converting the improper fraction back into the mixed number. So I'm going to go ahead and do my times E plus E. That's 24 plus 1 is 25/4. So now let's take 25/4 and let's just check and make sure that we did this correctly. 4 goes into 25 6 whole times. 4 times 6 is 24. 25 minus 24 is 1, so it's 1/4. I'm back to where I started. I know I did it correctly. Let's do another example. Let's turn this into an improper fraction. That's 15 plus 2 is 17/3. I can check my work by taking the 17/3 and turning it back into a mixed number. Well, 17 divided by 3, 3 goes into 17. Let's see, 5 whole times. 3 times 5 is 15. 17 minus 15 is 2. My remainder goes over my denominator. 5 2/3. I'm back to where I started. And lastly, let's do one more. 15 plus 4 is 19/5. Let's check that. Let's turn that back into a mixed number just to check our work. Well, I know 5 goes into 19 3 whole times because 5 times 3 is 15. There's a difference. 19 minus 15 is 4. So there's 4/5 remaining. I'm back to where I started. I know I did it correctly.